Hello everyone, in this video I'm going to teach you how to solve for the solution set of this given quadratic inequality. We have negative 6x squared minus x plus 2 greater than or equal to 0. Let's start. I'll solve for the solution set of this given quadratic inequality using its graph. Let's graph the quadratic function y equals negative 6x squared minus x plus 2. To be able to sketch the graph of this quadratic function, we need to know where the parabola opens. And we also need to know the x-intercepts of the graph. The graph of a quadratic function is a parabola. Okay? To know where the parabola opens, look at the value of a, or the sign of a. A is the leading coefficient. It's negative 6. If a is negative, the parabola opens downward. If a is positive, the parabola opens upward. So in this case, a is negative, therefore we have a parabola that opens downward. Next, we're going to look for the x-intercepts of the parabola. And to solve for the x-intercepts, we let y equal to 0. X-intercepts are the points on the x-axis, and the parabola will pass through those points. All the points on the x-axis have y coordinate that's equal to 0. That's why we set y to 0 in solving for x-intercepts. So change this to 0. We now have 0 equals negative 6x squared minus x plus 2. And then we solve for x. Let's transpose all the three terms to the left side. The sign of each term will change when being transposed to the left. We now have positive 6x squared plus x minus 2 equals 0. Then we can use any of the four methods to solve this quadratic equation. What are those four methods? The square root method, factoring method, completing the square method, and using the quadratic formula. I'll solve for x using the factoring method because the quadratic expression on the left is factorable. And I will use the AC method to factorize the left side. First, define ABC. A is 6, B is 1, there's an invisible 1 at the left of x, so B is 1. C is the constant term, it's negative 2. AC is the product of A and C. 6 times negative 2, negative 12. Factorize the product negative 12. The sum of its factors should add up to positive 1, or the B. What factors of negative 12 will give us a sum of positive 1, positive 4, and negative 3? Then we will split up the middle term of our quadratic trinomial. So we will have a 4-term polynomial on the left side. 6x squared. We will change positive x into 2 terms. Positive 4x and negative 3x. And then we copy the constant term negative 2 equal to 0. If we combine these similar terms, we will get positive x. Then we group the terms. Let's group the first term and the second term, and group the third term and the fourth term. 6x squared plus 4x. This is our first group. We also group the last 2 terms. The preceding sign of 3x is negative, and it's also the sign in between our 2 groups. Be careful when the sign in between the 2 groups is minus. Make sure that when it's distributed to each of the term inside the second group, the result will be negative 3x minus 2. This should be positive 2. Let's double check. Negative times positive 3x is negative 3x. Negative times positive 2 is negative 2. Next, we factorize each group. So the first group is 6x squared plus 4x. Factorize it using the Gcf method. The Gcf of 6x squared and 4x is 2x. Let's factor it out. Then we divide each term of the first group by their Gcf. 6x squared divided by 2x is 3x. 4x divided by 2x is 2. And it happens that the second group is prime or infactorable. So we just copy the second group. In case the second group is also factorable using the Gcf method, you should factorize it. Your goal is to have a common binomial factor. So as you can see, we have a common binomial factor and it's 3x plus 2. Let's factor it out again. Let's write the invisible numerical coefficient of this expression. It's actually negative 1. Divide each term by the common binomial factor. If you divide this by 3x plus 2, this will be cancelled. Left over will be 2x. If you divide this by 3x plus 2, this will be cancelled. Left over will be negative 1. And this is equal to 0. This is the factored form of 6x squared plus x minus 2. Let's double check. FOIL method, first term times first term, 3x times 2x, 6x squared. O, outer times outer, 3x times negative 1, negative 3x. I, inner times inner, positive 2 times positive 2x equals 4x. Then you add the outer and the inner products, negative 3x plus positive 4x equals positive x. L, last term times last term, positive 2 times negative 1 equals negative 2. Therefore, we have the correct factors. Next, we use the zero product property. Equate each factor to 0. Then we solve for x. First factor is 3x plus 2. Equate it to 0. Then let's solve for x. Transpose 2 to the other side. It becomes negative 2. We're left with 3x on the left. Isolate the x. Divide both sides by 3. X equals negative 2/3. We also set the second factor to 0, 2x minus 1 equals 0. Then solve for x. Transpose -1 to the other side, it becomes +1. We're left with 2x on the left side. Isolate the x, divide both sides by 2. We get x equals 1/2. These two values of x are the x-intercepts of the parabola. The parabola will pass through x equals -2/3 and x is equal to 1/2. Now, we know that the parabola opens downward. We know the x-intercepts. It's time to sketch the graph. Let's just plot the x-intercepts. Make sure when you plot, it's in the correct order. Smaller on the left, larger on the right. So this is -2/3 and this is 1/2. And then you just draw a parabola passing through these 2 points and opening downwards. This is the rough draft of our parabola. Okay. Next, let's consider the given inequality symbol. We're trying to find the solution set of -6x² minus x plus 2 greater than or equal to 0. That means we're trying to look for the points on the graph that are above the x-axis. The greater than symbol indicates all the points above the x-axis. The equal symbol indicates all the points on the x-axis. Remember, greater than is associated with above, less than is associated with on. Let's look at the graph. Let's start with points on the x-axis. Actually, the points on the x-axis are the x-intercepts of the parabola. So these 2 points are solutions of this given inequality. Points above the x-axis, all these points. Okay, so if you're going to graph this quadratic inequality, it's actually this portion of the parabola. I'll cover the portion of the parabola below the x-axis. This portion is the graph of this quadratic inequality. And when you are asked to give the solution set for this quadratic inequality, referring to its graph, it's actually asking you to give all the x values that will give you these points. And what are those x values? It's from here up to here. This range of x values is represented by the interval x is greater than or equal to -2/3 but less than or equal to 1/2. This is the answer. The solution set for the given quadratic inequality is x is greater than or equal to negative 2/3 but less than or equal to 1/2. This is expressed in inequality notation. X greater than or equal to negative 2/3 but less than or equal to 1/2. We can also express our solution set using the interval notation. We just write our left endpoint, it's negative 2/3. Write also the right endpoint, 1/2. And then you separate the two endpoints with a comma and enclose with brackets. We use the symbol brackets when we want to include the endpoints in the solution set. This bracket indicates that 1/2 is included in the solution. And this bracket indicates that negative 2/3 is also included in the solution. Another way to express our solution set is by set builder notation. By set builder notation, we use braces. And then we always start with x. All set of x, set of all x such that at the right of this vertical bar, you just write the inequality. This is the property of each of the element in the solution set. Negative 2/3 less than or equal to x, x less than or equal to 1/2. The solution set of the given quadratic inequality can be expressed in three different notations: the inequality notation, interval notation, and the set builder notations. If you want to validate your solution set, you can plug any number within this interval and try to find out the numerical value for the left side if it makes the statement true. Let's try one value, 0. 0 is greater than negative 2/3 but less than 1/2. Let's double check if this becomes true when x is equal to 0. If you substitute 0 into x, still the first term becomes 0 because 0 squared is 0 and any number multiplied by 0 is 0. This is 0, 0 minus 0, still 0. And we're left with positive 2. Is positive 2 greater than 0? It's true. And if you plug in the endpoints of the interval, for example, negative 2/3, the left side is exactly equal to 0. And this makes the equal symbol true. Let's try. X squared. If x is negative 2/3, x squared is 4/9. And what is 4/9 times negative 6? You reduce by 3. It's equal to negative 8 halves. And negative 8 halves is negative 4. If this is also negative 2, no, this is actually 4/9 times 6. It's equal to 24/9 reduced by 3. It's equal to 8/3. Negative 8/3. And negative 8/3 minus negative 2/3 is equal to negative 8/3 plus 2/3. What's negative 8/3 plus 2/3? It's equal to negative 6/3 or negative 2. Negative 2 plus 2 is exactly equal to 0, and 0 is equal to 0. That's why negative 2/3 is included in the solution set. Let's try 1/2. If this is 1/2, 1/2 squared is 1/4. Negative 6 times 1/4 is negative 6/4 or negative 3/2. Negative 3/2 minus 1/2 is negative 4/2 or negative 2, and negative 2 plus 2 is exactly equal to 0. 0 is equal to 0. So 1/2 also satisfies the given inequality. Okay? So if you have any questions or you want further clarification, just leave a comment. Please don't forget to subscribe to my YouTube channel. I am Tutor Marife MCP. Thank you for watching.